With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this question, basically, we have to identify which one of the following statement is correct. Okay, so let us analyze each and every statement. So the first statement is the elements having large negative values of electron gain enthalpy generally act as a strong oxidizing agents, basically. Okay, so let us understand the terms electron gain enthalpy and the oxidizing agents. Okay, so what do we mean by electron gain enthalpy? Suppose we have the element X in the atomic and gaseous form, okay, and we are adding one electron to this atom, basically, so it will get converted into a anion with the charge -1. Okay, so in this process the change in the enthalpy is known as the electron gain enthalpy. Okay, so here delta H will be delta H Eg. Okay, so suppose if our electron gain enthalpy is negative, that means the process which is mentioned above will be exothermic, and hence the process will be feasible. Okay, so we can say that if for an atom, if the electron gain enthalpy is negative, that means that particular atom is able to accept the electron easily. Okay, that means that particular atom can be easily reduced. Okay, so what we can simply say, that the particular atom will be acting as the strong oxidizing agent, because oxidizing agent is defined as that agent which has the tendency to accept the electron. That means which has the tendency to oxidize the other species. That means it can accept the electrons from that particular species. Okay, so we can say that high the negative value of delta electron gain enthalpy, more is the oxidizing property of that particular atom. So simple is that. Okay, so our A statement is true. Okay, let us consider the B statement, which is saying that the elements having the low value of ionization enthalpies act as a strong reducing agents. So let us understand what is ionization enthalpy. So suppose we have the element M in the atomic form and in the gaseous form. It has been converted into a unipositive cation M plus with the release of the electron. Okay, so in this case, basically the enthalpy which is accompanied will be the ionization enthalpy. Okay, so we can simply say that in the formation of the unipositive cation from the neutral atom, the change in the enthalpy will be defined as the ionization enthalpy. Okay, so if our ionization enthalpy is less, which this implies that our element M can easily be converted into the unipositive cation. That means it can be easily oxidized. Okay, so we can say that our element can be easily oxidized, and if the element is easily oxidized, then we can say that it can act as a strong reducing agent. So our this statement, which is statement number B, is also true. Okay, the third statement is the formation of S-2 gas from S gas is an endothermic process. So basically this statement is also correct. Okay, because if we consider the formation of anion from the neutral species, so this is our sulfur. Okay, and if we are forming the anionic species S minus, then in this case our delta H will be less than 0, no issues. Okay, and if we consider the formation of S-2 from S minus, then in this case our delta H will be positive. Okay, so in this case our electron gain enthalpy will be positive. And if we consider the overall reaction, which is S gas plus 2 electron forming S-2 gas, for this whole process our delta H will be positive. Okay, that means although the formation of union-negative species from the neutral atom may be negative or positive, okay, the enthalpy of that particular reaction is either positive or negative, but if we consider the formation of doubly charged anions, then for that particular case our electron gain enthalpy will always going to be positive. Okay, so it would be a endothermic process basically. So all these three statements A, B, C are correct, so we can say that our correct answer will be D. I hope that I made myself clear. Thanks for watching. Have a nice day.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.